and y show a direct variation relationship provided that y equals k times x, and this should say, and k can't be 0, so that fix that. The non-zero number k is called the constant. And sometimes you might see two words beyond that. You might see constant of variation, so either or. And so if I mention the constant of variation, I'm talking about this equation here. There are two ways you might see this equation written, okay? You might see y equals k, there'll be a number there, times x, or you might also see k equals y divided by x. And so if you wanted to box or highlight that as far as equations go, those are the two ways that you would see direct variation. Now, k can be positive or negative, but what you notice is, like, it's a line, right? But what's the y-intercept of that line? If I'm x plus b, b would be the y-intercept. What's in that spot? There's nothing there. So what's the y-intercept of this line? 0. Okay. All right, so right now, what I would like you to do is I want you to just tell me if this is yes or no, direct variation, and what k is. Try to do A through F. Look at your two equations up here. You can look with you can do this with somebody next to you if you want some help. So yes or no, and if it's a yes, what do you think k is? Okay, here we go. Yes, k would equal 3. No. Yes, k equals negative 1/2. No. Ooh, this one at first looks like no. It's a tricky one. Because if you moved x to the other side, it would be 7 minus x. Agreed? If you move x to the other side, what would we have? Help me out here. If I moved x, this x term to the other side, what would I would be subtracting it. It would be y equals negative 2x. Is this direct variation then? Does it look like this? Yep. And then how about this one? This does not look like the first one, but doesn't it look like the second one? Y divided by x is 1. So this is a yes. K equals 1. All right. The graph of a direct variation equation is going to be a line with a slope of k and a y-intercept of 0. So the line is always going to pass through the point 0, 0. So an example of this would be y equals 3/4 x. If it went through 0, 0, what's the slope? 3/4. Brian, what should I do then? If the slope's 3/4. He says up 3/4. That would be a line, and just extend that line. K can also be negative as long as it's kx. We're good. If it's negative x, really, what number is that? Dylan, what number could I squeeze in here? 1. So k here is -1. So this line would go through 0, 0, a slope of -1, down 1/1. All right, so if you're looking at graphs today, you're checking, does it look like a line, and does it go through 0, 0? Those are the two criteria. Okay. All right, probably this chapter, the most time we're going to spend on is direct inverse variation, but I find it hard as a teacher to talk about the one if I don't talk about the other. You guys have studied lines before in the past, okay? You have not studied graphs of things like this before. All right, so this one, two variables, x and y, vary inversely, inverse variation, if they are related as follows. So let's take a look now on this side at inverse variation. Okay. This time it's k divided by x, or what this would look like is k equals x times y. So these are going to be the two ways that you're going to see equations for inverse variation. Okay. The constant k is the constant of variation, and y is said to vary inversely with x. Tell whether the equation represents inverse variation. If so, identify the constant of variation. Okay, we're going to do this together. If you think this is an inverse variation, give me a thumbs up. If not, give me a thumbs down. A. Okay, this is a yes. K would equal 3. B. Good. You're seeing that this is the other way it can be written. This is a yes. K equals 10. C. This is a no. D. No. It's not over x on the bottom. This is actually direct variation, so no. E. This is a yes. K over x looks just like that one. Okay. K equals 6. F. Careful, careful. No. Okay. If the x and y are on the same side, they would be multiplied together in inverse variation. So this is a no. Okay. You have not we're not going to focus so much on the graphs tomorrow. We're going to actually graph some. But this is what the graph looks like of inverse variation. It's got these two curves, and it doesn't have a part of the graph right there. I want you to just look at this, okay? That's the graph of 1 over x, the most basic inverse variation. Why do you think the graph doesn't exist at 0? Think about what your math teacher might have taught you before about division. Let's see here. Abby, what has your math teacher told you about dividing by 0? Can you do it? You can't divide by 0, right? So it's undefined. So we call this an asymptote. I'll deal with that a little bit more later tomorrow. Okay, so equations and graphs. Do you feel like you can distinguish between the two? I hope after that. Then, now let's look at the tables and how do you find k? Okay, so if you're given a table of values, you might see a couple different ways. The tables either can be stacked horizontally. Do you see how the X's are on top and the Y's are on the bottom? Or you might see one stacked vertically. If you see it stacked vertically, the X's will be on the left and the Y's will be on the right. Either way, if a set of data represents a direct variation, you should be able to write a function rule in the form y equals k times x. How do you find k? What if you solved this for k? What would you do to both sides? This blue equation, if I said, hey, get k alone, what would you do to both sides? You divide by the x, right? Because it's multiplication. Okay, so if you ever want to find what k is, you're going to just simply take y and you're going to divide it by x. If you have an x and y value, you're going to do y divided by x, and that's always going to equal k. So k is equal to y over x. This is an indirect variation, okay? So if I wanted to check in a table to see if it was direct variation, what I'm going to do is I'm going to literally go in and I'm going to take each column and I'm going to take y divided by x, and I'm going to see if I get the same thing. These ones we can do in our heads, but you might need a calculator today to do this. All right, let's start. What's 4 divided by 2? 2. What's 8 divided by 4? I'm doing y divided by x. What's 8 divided by 4? 2. Keep going. What's 10 divided by 6? Uh-oh. Is that 2? I'm going to just write that because that's the important part of this table. And what's 12 divided by 8? Not 2. Did I get the same thing each time? I did not. This is a no. This does not represent direct variation. You would need to get the same thing each time. Alrighty. Like I said, if you need a calculator, get a calculator. We're going to check the k values here. What's negative 6 divided by 2? Negative 3. What's negative 9 divided by 3? Negative 3. What's negative 12 divided by 4? Negative 3. What's negative 15 divided by 5? Negative 3. This is a yes. What was k? Negative 3, so we literally can write our equation. Remember, our equation is y equals kx. Our equation is y equals negative 3 times x. Okay, so in summary, to check if it's direct, you take y divided by x. Okay, how do you find k? Use the data set x comma y to find your constant of variation and write the variation equation. Okay, so we're going to first find k, and then we're going to write it as y equals kx. How did we find k in the table above? What did we just do? Y divided by x. Let's do the same thing. So to figure out k here, we take y divided by x, and y divided by x is 9 over 6. I guess, what are ways you can write that? You can write it as an exact decimal, or you can reduce the fraction. If I divided those both by 3, wouldn't that be 3 over 2? So my equation would be y equals 3 halves x. All right, would you guys do this one for me? Try B. I got k equals -4, y equals -4x. Okay. Just be really careful in a word situation. And so in a word situation, you have to figure out what the x and the y is, but we're going to do it the same way. And I kind of give you some keys here. The amount of money M you make babysitting varies directly with the number of H hours you babysit. Okay? So the way that we take that statement is that second thing, the hours, determine the money, agreed? Think about your job. Does anyone have a job in here? Most of you are, it's based on how many hours you work, right? So your hours, your money depends on your hours. Okay, so let's figure out K. K is gonna be the money divided by how many hours it took me to do the task. $24 for 2 hours. 24 divided by 2 is 12. So the money you get is $12 per hour. So how would you figure out for 4.5 hours? Wouldn't you just multiply it by 12? Because it says, how much money would you make if you babysat for 4.5 hours? Okay, somebody do that for me on their calculator. And would you share with us? $54? You're just doing it in your head? Good. Well, either do it in your head, but if you can't do it in your head, you should do it on a calculator. Somebody who did it confirmed that he got that, right? That's $54. Okay, good. All right. How do you find K? So remember in here we did y divided by x. How do you find K if it's inverse? So since the inverse variation equation has the form y equals k over x, if you solved for both sides, you would multiply both sides by x. And a table has an inverse relation if when you multiply the x times y, it gives you the same ordered pair. The product should always equal k. All right, so we're multiplying this time. We're gonna check the x times y. All right, so what's 1 times 48? Yep, 48. What's 2 times 24? 48. Shout it out. 3 times 16. Is it 48 or not? Yes. Okay. 4 times 12. Okay, you're probably going to do that one on your calculator. 5 times 9.6. Yay. All right, now we found K. K is 48. So the two ways you can write your equation are 48 equals x times y, or you can write it in this way. So you can write it that way, or y equals 48 divided by x. Those would be the two ways you could write that equation. Okay, without spending a lot of time on B, because I don't want to insult your intelligence, do you all understand why B is not direct variation? It's pretty clear after the first one that these products are not going to be the same, huh? Okay, so this is a no. All right, so summary. How do we find K when it's inverse? What do we do with the x and the y? Yeah, when it was direct, did I say direct? I meant inverse. When it was direct, we divided. This time we multiplied, right? So today when you see this and I say it's inverse variation, what we're going to do is we're going to take our x and our y and we're going to multiply them together, okay? So k equals x times y. Somebody multiply for me 9 times 36. And what do you get? K equals 324. And if you wanted to write that in one of these ways above, your equation would be y equals 324 divided by x. Oh no. Uh-oh. Gotta fix that. So, last thing. What do you do in a word situation? We're going to do the same thing. The hard part about a word situation is figuring out which is x and which is y, but we're still going to multiply them together. When setting up for a party, the hostess noticed the number of bananas varied inversely as the number of watermelon. Okay. Bananas are inversely as watermelon. That's how you write that statement. Okay. Bananas varies, the k is the constant, inversely as the watermelon. Okay. In other words, how are we going to find k? We're going to find k by taking the number of bananas times the number of watermelons. Okay. Using this sentence, a table has 4 bananas and 5 watermelons. What is k in that situation then? Isn't k 20? All right, if another table had 7 bananas, all right, let's write our equation then. The bananas is going to equal 20 divided by the watermelon. If another table had 7 bananas, how many watermelons would be needed to keep the proportion the same? Ooh, how do I do that? Well, you can think of it this way. Didn't we learn that the bananas times the watermelons is going to always equal 20, right? How many bananas do I have? 7, right? I don't know the number of watermelons. I want it to equal 20. Okay. Now, is this going to be exact? No, give me a decimal, would you? What is that? Okay. I don't know that anybody's going to measure 2.85 watermelons, but maybe you'd be safe to put about 3.